Okay, we're working today on finding 5 points to graph trig functions, and we use a method that we call the box method. In the box method, if I'm going to be working with a general sine equation, it will help me find these 5 points for sine, because our sine wave does this. So for instance, our general equation is y equals a sine bx plus c plus d. And this would allow me to find these 5 points for any general equation for sine. So for example, if I said y equals 2 sine 2x plus pi over 2 plus 2. And sometimes it's hard to graph that on a coordinate plane. So this box will help me do that. Now, D is our vertical shift, and that is always placed right here in the center. So there's the 2. A is our amplitude. It's out in front. It tells us how high that this is going to go. So it'll go up to 4 and down to 0. 2 right here is B. This B tells us our period. So the period is 2 pi over b. Period 2 pi over b. So that would tell me that this is pi. Take half of that, that's pi over 2. Take half of that, that's pi over 4. This would be 0. This would be 3 pi over 4. And finally we have our horizontal shift, which is found by taking what's inside here, 2x plus pi over 2, and setting it equal to 0, and solving for x. So we would get 2x equals negative pi over 2, so x is equal to negative pi over 4. What this tells us is that this graph is shifted left by pi over 4. That's why it's negative pi over 4. To put that on the graph, all we would do is put this as minus pi over 4. It's always the same value right here. And then subtract pi over 4 from each of these. And those are our points. So I would set up my graph. And I make the x-axis obviously longer so I can get a better look for what's going on. But that would be pi over 2 pi, 3 pi over 2, 2 pi, obviously 1, negative 1. So if I were to graph a regular sine at 0, 0, at pi over 2 it's 1, pi at 0, 3 pi over 2 it's negative 1, 2 pi at 0, and so this would come up, come back down, go down, and then come back up. And that is one cycle from 0 to 2 pi for sine. Our new graph has been shifted. It has been shifted to the left by pi over 4, which is halfway in between here. So it's at negative pi over 4, 2. Negative pi over 4, 2. This point is at 0, 4. So 0 up to 4. This point is at pi over 4, 2. So here's pi over 4. It's halfway in between. 2. Pi over 2, it's at 0. That would be right here. 3 pi over 4, it's back to 2. So our new graph does that. And that's how we use this to find these 5 points, to plot them on a coordinate plane. This would be your normal sine x. These 4 numbers have changed this normal sine x to this graph. And again, this is only one cycle. This continues on this direction, this continues on this direction, just like this continues on here and this continues on here, because they are infinite. And that's how we use the box method.